Hello, so I had a comment, Riyadh made a request about looking at the connections between the Lucas and the Fibonacci numbers, and okay, so Fibonacci and the Lucas numbers. Fibonacci begin 1, 1, 1 plus 1 is 2, 1 plus 2 is 3, 5, 8, 13, 21, etc. The Lucas numbers are different in that they begin with a 1 and a 3, because if we began 1 and 2, we just have the same thing. So 1, 3 is 4, 3 plus 4 is 7, 4 plus 7 is 11, 7 plus 11, 18, 29, 47. So those are the Lucas numbers. And before I have a look at that, let's just look at the spirals, and we'll do the Fibonacci and Lucas spirals are both nice in that they can begin using the Vesica as a origin point. And so I'll begin by drawing a Vesica. One circle, second circle is the center on the second. Okay, what we have now is 1, 2, 3 wide and 1, 2 high. So Fibonacci is 2 to 3. You've already got the beginning of there. I'll put some links in the description. Okay, well, what we already have though is, so what we can do is we can just going to freehand. So we've already have a square. Now, to draw any of these spirals, all it is a series of quarter circles is one of the better ways to draw it. It's not the only way, but I think it's the better way, because we already have a square which is 1 by 1, the first two Fibonacci numbers. The next one is a 2 by 1. All right, so now we have a 2 by 1 rectangle, which is just another quarter circle there. So we already have the beginning of the Fibonacci spiral. Now to continue that, I'll change the color. Now to continue the spiral, all you do is you readjust. So that's 1 by 2 now. To continue that spiral, all you do is you readjust your compass to the longest edge of those rectangles. So the next Fibonacci, next part of a spiral, again we just do a quarter circle, just 1/4 of a circle, and now it is a 1 by 2, now it's a 2 by 3 rectangle, which is the original proportions of the Vesica, 2 by 3. So now we're at, that was 1 to 1, this is 1 by 2, now we have a 2 by 3. So now we readjust it to 3, and just continue another quarter circle, and now we have a 3 by 5. And if we just readjust that, again I'm just being very quick, if you want to do the take the time to do the construction. Okay, 3 by 5. And we would continue running off the page there. Okay, but now we have the beginning of this Fibonacci spiral. And so it's a quarter circle, quarter circle, quarter circle, quarter circle, quarter circle. And what's really nice about this phi ratio is that as you draw this spiral out, it looks natural. So this is a quarter of a circle, that's a quarter of a circle, but to the eye, it appears to be smooth. It's not like if you, again, draw a circle and try to place it on like a tangent, or it looks odd, it looks strange. But at this ratio, this is pretty much the maximum growth that you can have in a quarter circle, where it still looks pleasant, looks like it's actually a spiral, not a series of 1/4 circles. So that's the Fibonacci numbers: 1, 1, 1, 2, 2, 3, 3, 5, 5, 8. But back to the Lucas numbers, and the Lucas numbers is nice. So let's just draw those. So okay, Lucas numbers this time: 1, 3, 4, 7, 11. And what's nice about the Lucas is that Fibonacci often gets the most attention, but especially when it comes to the Great Pyramid, for instance, it's actually the Lukas numbers which are a better descriptor of it. And then this time I'm going to draw a construction line. I'm going to do it horizontal. And I'm going to draw a Vesica once again. And so the Vesica is at a 2:3 ratio. However, it does give us all the construction points we need, because this rectangle is 1 to 3. 1 to 3. Now, we follow those same rules. We find the longest edge length, set our compass to there. Okay, that slipped. Compass point slipped out a little bit. Good enough. So, just again with 1/4 of a circle, we now create a rectangle which is 3 to 4. 1 to 3, 1 to 3, 3 to 4, 3 to 4. Change the compass again, and again this spiral would grow in such a way that it appears that it's a spiral, not a series of quarter circles. So now we have a one to 3, 3 to 4. Now we have 4 to 7, and now we set the compass again to the longest edge, another quarter circle, and again you get this natural looking spiral. But what's good about the Lukas numbers is, so we have 1 to 3, 3 to 4, 4 to 7, and now we have a (7 to 11). And I'm just going to eyeball that. Now, what we have now is the Great Pyramid, which is 440 wide, 280 high, or a 7 to 11 ratio. So this would be the Great Pyramid if I was to spend the time. Okay, but what we have is the angle here. I've got it written down, the exact angle. You know, if we had drawn this nicely, but I'm just for illustration purposes, that would be 51.84277 degrees. If the half base is 1, then this would be 1.6185903.4. Very close to the golden number. And if the half base is pi, then the height would be 4, or a very close approximate of it. But so the Lukas numbers, 7-11 ratio, again this nice connection to the Kepler triangle. I'll put that link in the description, which is this perfect phi triangle, but this is very, very close to the Kepler triangle, and by definition it's the Great Pyramid angle as well. However, the Great Pyramid, slight variations on each side, so you need to take that into account. But from the Vesica, all we did was cut it in half to create a 3 to 1, and we had the same drawing there. Again, the Vesica. We also have the Fibonacci spiral. So that's how you can draw those. But what's really cool about the links between the Vesica and the Fibonacci numbers, clean this up, they've got the same connections and properties going now.
Okay, so just to quickly spreadsheet the Fibonacci and Lucas and do a comparison. So first we just begin with what order they go in. So I'll just hit 1 and hit equals, the number above plus 1. So that's just going to give us the order of them just to help keep track. So 1, 2, 3, 4, 5, okay, 7, 8, 9, 10, etc. The Fibonacci numbers begin with 1, 1. Underneath that, hit the equals, and then we add those two. So the one above and plus the one above. And again, just that little black box in the corner, you can just drag that down. There we have our Fibonacci numbers. Now the Lucas numbers, they begin with 1 and 3. And so underneath equals the number above plus the number above that. And there we have 1, 3, 4. Drag that down and you have the Lucas numbers. Because they grow in the same way, they just add the number previous to it. What you're going to have is this Phi ratio, golden ratio. So now I'm going to hit the equals, divide by the previous number, and of course 1 divided by 1 will be 1. But there you can see again, so the golden number 1.6180339. It's just going to get closer and closer and closer to it. It's never going to quite match. So that's well known, Fibonacci and the connection with but what happens is, because the Lucas numbers grow in the same way, you're always going to get this happening. And so divide the 3 by the 1, so just divide by the number above it. And Lucas number begins, so Fibonacci begins with 1, Lucas begins with 3. But if you drag those down, so they start very, very quickly converging on 1.6180339. So Fibonacci and Lucas numbers will share those things. That's not unusual. It's also worth noting that, let's bring up the calculator. Pi divided by 2 is 1.5079. That's 1.5071428571. This could be repeated, but 11. So that's 11 divided by 7. Very good approximate of pi, but we'll get in. Not so. That's basic. 7 and 11 is the Great Pyramid ratio. But it's also worth noting the. Okay, so let's get a diagram. So that's the Great Pyramid, 7 to 11. This is idealized, but there we see the proportions. That's the angle if you create a 7 to 11, and it's 1.6185934, blah blah, etc. It carries on. Now it's actually the 11th. That's the closest you'll get to that ratio of the Great Pyramid slope, idealized, because it is much better than if you include the variations, but 1.6186. And it's actually the Lucas series that has the closest to that. So Fibonacci are okay, but if you want the closest as a fraction would be 123 divided by 76 is the best of the Lucas and Fibonacci. That's the best one to use. Okay, also worth mentioning, someone mentioned the repeating cycle in the Fibonacci numbers. And well, look at the Lucas numbers, and so there's the Lucas numbers 1, 2, 3. So there we have the first, the second, the third, but there we have the Lucas numbers. And I don't know how to spreadsheet to get these digital roots. I had to do that manually, but because 1, 3, 4, 7, because they're single digits, of course. But the first double digit is 11, and you get 2. For instance, 1 plus 8 is 9. 2 plus 9 is 11. 1 plus 1 is 2. And well, again, the Fibonacci get this attention, but it's basically the same thing seems to be going on in a variation in the Lucas numbers. And so the largest single digit number is 7, and every 8th number from what I've, so the 4th plus 8 is the 12th is 7, plus the 20th is 7, 28th is 7, 36th is 7. So, but also 9 and the 6th, every 12th number, at least from what because I had to add these up. I don't know how to do the digital roots programming that well, but it does, at least on the surface, appear that even the Lukas numbers would have this repeating digits, and that would probably suggest that if you were, if you know how to program a spreadsheet to automatically do this and you can run it through, I would probably suggest that there is a repeating digit series that goes on in, if you'd expand this out, I could be wrong, I've only gone up to 36, but in the Lukas numbers there is this repeat digit in the 12th, and also every 8th is the 7th number from what I've done. Again, this was just done quickly manually to add these numbers up. But again, I would suggest, again, there's probably a little bit of too much attention to the Fibonacci's in that form, because at least on the surface, Lukas numbers is the same. If you were to just do an arbitrary series and build it up the same way, I would suspect that this cycle repeats as well. But that's just an observation just based on the first 36. Possibly this could fall apart if I was to extend a little bit further, but yeah, again, I don't know how to program the spreadsheet to do this automatically, so I can't run it, through hundreds and hundreds of operations. But I would think, at least I'd be very suspicious that this does not only just does it happen in the Lukas numbers, but probably any series you would get this repeat digits. At least I suspect, but who knows? Anyway, that's worth considering too.
Okay, so I've just looked at the spreadsheet. If you do the Fibonacci and the Lukas numbers, again, how they're going to approach the golden ratio, the golden number, or phi, or 1.618033398887. Okay, on and on it goes. But okay, so there you have your golden number, and how both the Fibonacci and the Lucas, because they grow in the same way, just like any series that grows in that way will have a golden number. That's not unique to either one of those, but what's in terms of nice links between the Fibonacci and Lukas numbers, and so first we okay, so the number, so okay, so there are some nice links that bring the Fibonacci and Lukas numbers together. So let's, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Screen. So let me get this paper off and get it all in screen. Okay, and what we want to go is up to 12. You could go on, but so that's just which one they are. So the first Fibonacci is 1, the second is 2, 1 plus 1 is 2, and 3, 5, 8, 13, 21, 34, 55, 89, and 144. Okay, that's all in screen. So I'm just going to put the Lukas numbers next to those. And we have 1, 3, the third is 4, 7, 11, 18, 29, 47, 76, the 10th is 123, 199, and then 322. We'll come back to it, but just to begin with, a nice thing about the the 12th Fibonacci number is square root of 12. So 12 squared equals, or a gross, 144. But this is a nice thing, we'll come back to that. But so obviously this series, if I just keep dividing for one by the one before, both on the Fibonacci and Lucas, I'm going to come closer and closer to the golden number, or Phi. Okay. Just in case that's out of screen, Phi, golden number, divine proportion, all different types of names for it. But how do the Fibonacci and Lucas connect? Very, very nicely. And okay, so firstly, let's take every second Fibonacci, we add them together. So 1 plus 2 equals 3. Okay, we follow that pattern again. 1 plus 3 equals 4. Follow that pattern again. 2 plus 5 equals 7. 3 plus 8 equals 11. 5 plus 13 equals 18. 21 plus 8 is 29. 13 plus 34 is 47, etc., etc. So that's the first nice link between the Fibonacci and the Lukas numbers. But okay, I did a video recently, triangular numbers, the Tetractys, Tetragrammaton. So let's put triangular numbers in for a second. And triangular numbers are 1, 3, 6, 10, 15, 21, 28, 36, 45, and the 10th is 55. The 10th Fibonacci is 55. The 10th triangular number is 55. The next is 66, and then 78. So firstly, the 10th triangular number is also the 10th Fibonacci number, and they happen to add up to 10 is nice as well, but not the point. But also, as I showed the earlier video, okay, so if we add the triangular numbers, 1 plus 3 is 4, that equals 2 squared. The first plus the second equals 2 squared. The second plus the third equals 9, equals 3 squared. The third plus the fourth equals 16, or 4 squared. And this pattern carries on and on. But it's also worth noting, so therefore the 11th plus the 12th triangular number equals 144, equals 12 squared. And the 12th Fibonacci number is 12 squared as well. So there's a nice tie-in with those as well, but there's still more to it. And have my wonderful paper. So now let's slide the paper over, because I want to keep the Fibonacci and Lucas numbers. And so again, the first plus the third Fibonacci equals the Lucas numbers, but the same thing can go on again. And so let's start with Lucas and Fibonacci. Actually, sorry, I'm going to reverse that around. Fibonacci and Lucas numbers. And so the first, second, third, fourth, yep, I'm in. 5th, 6th, 7th, 8th, 9, 10, 11, 12. So 1, 1, 2, 3, 5. 5th Fibonacci is 5 as well. It's a nice one. 8, 13, 21, 34, 55, 89, 144. So the Lucas numbers 1, 3, 4, 7, 11, 18, 29, 47, 76. 10th is 123, 199, and then 322. And again, so begin with the 10th. Okay, and the 10th is 55. So half of 10 is 5, of course. Now, 5 times the 5th Fibonacci times the 5th Lucas equals 55. So the 10th is 55 Fibonacci. Half of that is the 5th row. 5 times 11 is 55. So if we go to 8, okay, half of 8 is 4 and 21, okay. 3 times 7 equals 21. So try it. So half, okay, so try it again. 6, half of that is 3. The number you want is 8. The third Fibonacci is 2. The third Lucas is 4. Equals 8. So there's a nice join with those as well. And this is just a nice patterns that carry on with them. Again with the Lucas 7 and 11, so 11 over 7 is a very, very good approximation of pi over 2. With drawing the Lucas spiral, it creates a 7 to 11 rectangle, and also this number here is best represented by the Lucas numbers 100. So the 11th Lucas number divided by the 10th Lucas number, so 199 over 123 is 1.61842, I think, okay? But that's of this Fibonacci and Lucas series. The closest you're going to get to 1.61856, the idealized pyramid angle, is this number here represented by the Lucas numbers. So when it comes to the golden number and the Great Pyramid, not only is the Lucas spiral better, I would say, than the Fibonacci numbers, it's also, as in terms of proportion, it comes much better. There'd probably be another, a better fraction than that to get this number. But in terms of Fibonacci versus Lucas, the Lucas numbers would be the better of the two. So again, 10th Lucas number, sorry, the 10th Fibonacci number is 55. Half of 10 is 5. The 5th Fibonacci times the 5th Lucas number equals 55. The 8th Fibonacci number is 21. So half of that is the 4th column. 3 times 7 is 21. The 6th Fibonacci number is 8. Half of 6 is 3. The 3rd Fibonacci times the 3rd Lucas number equals 8. So they're nicely linked in that way. Or alternatively, the first plus the 3rd, so just every second Fibonacci adds to the Lucas numbers. But there's another nice thing, because we come back to the golden number, and here's where the Lucas numbers really shine, because there's another nice alternating pattern that sort of joins them together. And so, like if you do it in a calculator, you're going to get 99.9%. You want this would run on almost to infinity, the perfect golden number, but it's as good as you're going to get. Now, so the Fibonacci's, the first plus the 3rd equals the 2nd Lucas. The 2nd plus the 4th Fibonacci equals the third Lucas, okay. So they link, but now here's what's cool about, so let's just look just at the Lucas numbers and Phi. Okay, I'm in screen. Okay, so the first, second, third, fourth, fifth, sixth, seventh, eighth. Okay, we could go on and on. Let's just do it to the 10th. The 1, okay, 3, 4, 7, 11, 18, 29, 47, 76 and 123. How do they connect to Phi? So this is the first, the second, the third, the fourth, okay. Now let's think of them as dimensions. And how do they join to Phi? Well, let's look. So Phi minus 1 over Phi equals 1. Now next, that's an odd number. Okay, even number, Phi squared plus 1 over Phi squared equals 3. The third, it's an odd number. The third is third Lucas number. Third dimension, Phi cubed minus 1 over Phi cubed equals 4. Okay, so the fourth, this is an odd number, is 7. Phi to the fourth plus 1 over Phi to the fourth, sorry, this should have been Phi to the third, equals 7. So the fifth is 11, and okay, Phi to the fifth power minus, because it's an odd number, 1 over Phi to the fifth equals 11. Now it's an odd number, sorry, even number, 18, okay? Phi to the sixth plus 1 over Phi to the sixth equals 18. When it's an odd number, you minus. When it's an even number, you plus, and you just grow. So the first dimension, the second works in the second dimension, the third to the third power, the fourth to the fourth power, and it just carries on like that. So Phi to the seventh, odd number, minus 1 over Phi to the seventh equals 29. 1, 3, 4, 7, 11, 18, 29. Lucas numbers 1, 3, 4, 7, 11, 18, 29. It just carries on. Odd number, sorry, even number, the eighth to the eighth power plus 1 over Phi to the eighth equals 47. And on it goes. So there are lots. Any series that grows like the Lucas or the Fibonacci has these qualities, but there are some unique things to link the Lucas and the Fibonacci, and also the triangular series, or Tetractys, the Pythagorean Tetractys, or the Tetragrammaton, as in Kabbalist tradition, and it works in dimensions, multiple dimensions, and it just, yeah, it's really lovely stuff. You can draw it geometrically, you get the Great Pyramid, or, yeah, so Lucas and Fibonacci numbers, really worth investigating. Have a good one.